Antarctica, the coldest, windiest, most remote place on Earth. And yet, on this frozen ice sheet stands Halley VI, one of the most advanced research stations ever built. Most structures here vanish under meters of snow, eventually crushed by its weight. But not this one. This station rises above the snow and can be moved across the ice, making it the first fully relocatable research facility in the world, a marvel of modern engineering. But what makes this station unlike anything else on Earth? In this video, we've modeled the entire station inside and out to break down its design, uncover how it was built, how it works, and show what life is really like inside the world's most extreme laboratory. Covering the southernmost part of the globe, Antarctica is the fifth largest continent, larger than Europe, and is covered by a vast ice sheet averaging 1.9 kilometers thick. It was first discovered in 1820 by the Russian expedition led by Fabian Gottlieb von Bellinghausen and Mikhail Lazarev. Antarctica is the land of extremes, with 24 hours of sunlight in summer and total darkness in winter. Even in the warmest months, temperatures rarely rise above -10 degrees Celsius, and in winter, they can plunge far lower. The coldest temperature ever recorded on Earth, -89.2 degrees Celsius, was measured here. Despite its brutal conditions, this is one of the most important places for studying climate change. Its isolation and sensitivity to global shifts makes it a natural laboratory, one of the last truly untouched environments on Earth. By drilling deep into the ice, scientists uncover climate records going back hundreds of thousands of years. They also monitor space weather, the ozone layer, and global systems like ocean currents and jet streams. Halley VI is one of many international research outposts here, each contributing to the bigger picture. But what sets it apart isn't just where it is, it's how it was built. Before Halley VI, 5 earlier stations were eventually lost to drifting ice and crushing snow. To understand why this one had to be different, we have to look at its past and the treacherous ice it stands on. And by the way, to go along with this story, we've created a limited edition poster of the Halley VI station. More on that later in the video. For over half a century, scientists battled the brutal Antarctic environment. The Brunt Ice Shelf, where the Halley VI now sits, is no ordinary foundation. It's a 150-meter thick floating slab of ice that now moves about 1.5 kilometers per year toward the Weddell Sea, which is part of the southern ocean surrounding Antarctica. The shelf is prone to massive cracks that can stretch for hundreds of meters and shear off without warning. And each year, over a meter of snow accumulates, gradually burying any structures built until they collapse under the pressure. Since 1956, the British Antarctic Survey has attempted to overcome these challenges. The first base, Halley I, was built on what became known as Halley Bay, named after astronomer Edmund Halley. Over the decades, Halley II through V experimented with different construction styles, wooden huts, reinforced buildings, and even steel tunnel systems, but none of them lasted. Clearly, surviving in Antarctica on a floating ice shelf would require a station built differently from anything before. When Halley VI officially opened in February 2013, it wasn't just another research station. It was a blueprint for survival. Built to rise, relocate, and withstand the extremes, its construction pushed the boundaries of what's possible in one of the harshest places on Earth. Laid out in a straight line across the ice, Halley VI stretches approximately 190 meters in length, about the length of 2 American football fields, and consists of 8 large, hermetically sealed modules. Each module was prefabricated in Cape Town, South Africa, shipped by cargo vessel, and assembled during the short summer months. Using cranes and a factory line approach, the modules were first put together near Halley V, then towed 15 kilometers inland, proving the concept of a fully relocatable base. Of the 8 modules, there are 7 blue modules which house living quarters, labs, and essential systems, and 1 central, 2-story red module to serve as the communal hub for eating, socializing, and gathering. Each blue module measures about 10 meters wide and up to 10 meters tall, roughly the length of a city bus. The red module is even larger, about 15 meters wide and tall, comparable to the length of a semi-trailer. For safety, the base is also split into 2 self-sufficient platforms, each with its own power and life support. A raised bridge connects them and allows the sharing of power, drainage, and water. In an emergency, one side can operate independently and support the entire crew for up to 10 months. It also acts as a fire break, preventing a blaze from spreading between the platforms. The modules themselves are joined end-to-end with flexible silicone rubber connectors that link the interiors into a single continuous space. These connectors were custom designed for the station to handle significant positional tolerance and withstand extreme cold, and are similar to the connectors used between train cars. The station's shape is functional and strategic. Built perpendicular to the wind, snow naturally drifts to the leeward side, leaving the windward side clearer so vehicles can move along the station more easily. The module's design also harnesses the wind's scouring effect to reduce snow buildup under the module. Each module is supported by hydraulically driven legs that allow it to be raised and lowered. A large ski at the base of each leg spreads the load and prevents it from sinking too deeply into the snow. These skis also enable each module to be towed individually across the ice when the station has to be relocated. At the end of each winter season, snow gradually accumulates around the module. Eventually, the station must be lifted before the snowbanks grow too high. To do this, each leg is raised individually. Snow is then pushed and compacted beneath the elevated foot, creating a higher base. The leg is then lowered onto this new surface. Once all the legs have been adjusted, the entire module is lifted to its full height. Finally, dagger boards are driven into the ice to anchor each module securely in place. Living here means complete isolation. In summer, when research activity is at its peak, the base can support up to 50 people. A mix of scientists, engineers, mechanics, a chef, and a doctor. In winter, when operations are scaled back, that number drops to around 15, or sometimes 0, depending on ice conditions. Resupply for essentials such as food, fuel, and equipment typically happen just once a year, during a narrow 2 to 3 week window when sea ice conditions are stable enough for a ship to safely reach the ice shelf and offload cargo. The station relies on the sea for most deliveries, and the ship's arrival is the biggest event of the year, bringing fresh supplies, rotating personnel, and removing accumulated waste. Flights are also used to transfer personnel, but cargo capacity is limited because Halley VI skiway can only accommodate small aircraft during the summer months. These planes not only have limited space for supplies, but also lack the range to fly directly from southern Chile or South Africa without multiple refueling stops. In winter, the crew is completely isolated. No flights, no resupply, no evacuations. Regardless of how supplies are brought in, everything must be delivered in accordance with the Antarctic Environmental Protocol, which imposes strict rules on pollution and waste. The station must function as a sealed, self-sustaining system for months at a time. That level of independence comes from how every part of the station is designed to work together. So what's actually inside this futuristic outpost? Let's take a closer look. From the outside, Halley VI looks like a futuristic train stretching across the ice. But inside, it's carefully organized to keep science going at the edge of the world. And it was designed at its core to withstand extreme conditions. The station's 8 modules were built with robust steel space frame substructures and braced portal frame superstructures. Ultra-isolated lightweight fiberglass cladding panels were bolted to the steel frames and finished with a protective outer layer designed to resist UV radiation, discoloration, and abrasion from wind-blown snow and ice. The blue modules each have an internal floor area of about 150 square meters, about half a tennis court, and weigh between 80 to 95 metric tons, roughly the weight of a fully loaded Boeing 737. The red module has nearly twice the floor area and about 3 times the weight of a single blue module. The first 2 modules serve as sleeping quarters. The first sleeping module has 8 rooms with 2 bunks each, where station personnel can rest and recuperate after long shifts. Storage rooms provide space for storing various items, while a quiet lounge with panoramic windows offers a relaxing space to decompress. The windows throughout the station are triple glazed and feature a solar reflective coating helping to minimize glare, retain heat, and allow diffused daylight into the station. The second sleeping module also has 8 rooms with 2 bunks each along with storage, but instead of a lounge, this module includes 3 restrooms and 3 shower rooms, essential spaces for staying clean and warming up. To help with mental health, bedrooms across the station feature daylight simulating lights to ease the effects of seasonal affective disorder. Even the interior color palette was developed in consultation with a psychologist to offset sensory deprivation and boost mood. And even with all that, spending months in a place this isolated with 24-hour darkness and no way out can still take a toll on mental health. It's easy to imagine how that kind of isolation wears on you. And the truth is, you don't need to be in Antarctica to feel that way. Life can be overwhelming in quieter ways too, when things don't go how you thought they would, or when you start feeling a little disconnected from everything around you. And sometimes it helps to talk to someone who's trained to guide you through that. This next part is a paid partnership with BetterHelp. A credentialed therapist can listen, ask questions, and help you see things from a new perspective. They can offer tools to help you cope, shift, and move forward. BetterHelp is on a mission to make starting therapy easier. You just fill out a questionnaire and get matched with a therapist as soon as possible. If it's not the right fit, you can switch anytime at no extra cost. They've got over 7,000 reviews and a 4.3 rating on Trustpilot, so it's a platform people trust. Click on the link in the description or go to betterhelp.com/deconstructed to get 10% off your first month therapy. The command module houses critical functions, including the communication office, which serves as the central hub for all contact with the outside world and acts as the station's air traffic control, the server room containing the station's network infrastructure, and the infirmary and doctor's office for medical care. It also contains the base commander's office and the laundry room. The command module also contains the boot room, which serves as the main entry point into the station. To get inside, personnel climb a staircase to an elevated external door, which also acts as the cold weather airlock. Just beyond the door is the boot room, where outerwear can be hung up to dry and snow-covered gear is left behind. This space acts as a thermal buffer, keeping the cold out and the warmth in, so the interior stays clean, dry, and stable before anyone steps into the heated living areas. Next, at the heart of the station is the red module, also known as the Robert Falcon Scott module, named in honor of the British explorer who led early Antarctic expeditions. This 2-story central hub serves as the social core of the base. On the first floor, it houses a full kitchen with a walk-in freezer and refrigerator, a dining area where staff gather for meals and celebrations, and a cozy lounge and bar for unwinding after long shifts. The second floor includes a gym to help crew members stay active during the long winter months, as well as a media room with a TV and computer. Connected to the red module is the first power and plant module, which houses 2 generators that power the station. These aren't ordinary generators. They're combined heat and power units. Instead of letting the valuable heat produced by the engine escape into the atmosphere, the system recovers it in 2 ways. First, the hot engine coolant exiting the engine flows through a heat exchanger. Inside, the coolant passes through a series of small tubes before exiting at the other end of the heat exchanger. In a separate circuit, cold water circulates around these tubes, guided by internal baffles to absorb as much heat as possible from the coolant. Then, the heated water flows through a second heat exchanger, where the engine's hot exhaust gases pass through before exiting the station. The same principle applies. Heat transfers from the gases flowing inside the tubes to the water circulating around them, heating it even further. The heat exchangers are so efficient they can reclaim up to 60% of all heat that would otherwise be lost. The now hot water is then moved into a large buffer tank that temporarily stores the recovered heat. From there, it circulates through a closed-loop system to warm the modules, produce domestic hot water for the showers and faucets in a separate tank, and melt snow for the station's water supply. Once the heat is used, the cooled water is sent back to the generators to restart the cycle, all without additional fuel consumption or emissions, helping reduce the station's environmental impact in Antarctica. Opposite to the generator room is the water treatment plant designed to produce drinkable water. Here's how potable water is produced on the station. Located beneath the service bridge that connects the two module platforms are two melt tanks, which are filled with snow every few days depending on the season. Inside each tank, hot water generated from recovered heat circulates through a coil to melt the snow. Although Antarctica holds 90% of the world's surface freshwater, water conservation is extremely important at Halley, since melting snow is one of the station's most energy-intensive tasks. Once melted, the water is pumped into a buffer tank, pressurized, filtered through a micron filter to remove particulates, and disinfected with a UV sterilizer, producing potable water for use throughout the station. This module also contains a fuel tank for the generators as well as a waste room where all the station's waste is collected and stored until it is safely removed. From here, essential services like power, hot water for heating, and domestic cold and hot water are distributed through a heated zone beneath the floor, insulated from the cold. Next up is the second power and plant module, which includes 2 additional generators, 2 more fuel tanks, and a boiler room. This module also houses a compact sewage treatment plant designed to treat wastewater so it can be safely discharged into the environment or reused. To minimize water usage, the base employs a vacuum sewer system that removes waste by suction, similar to the systems used on airplanes. This design drastically reduces water consumption, using up to 90% less water than standard toilets, and eliminates the need for large-diameter gravity piping. Gray water from showers and sinks is filtered through a micron filter and disinfected with a UV sterilizer before being collected in a storage tank. From there, it is pressurized and used for toilet flushing and other non-potable uses. Black water from toilets and kitchen sinks is processed in a biological treatment system where bacteria break it down. The process produces gray water, which is returned to the gray water storage tank, and sludge, which is bagged, frozen, and transported out by ship. Continuing down the station is the first science module, which supports research and related operational activities. It includes a shared office area, laboratories, workshops, a restroom, and a second boot room for alternate entry and exit. Finally, the last module, the second science module, spans 2 floors. The first floor features offices, workshops, and an emergency food store. Upstairs, the second floor houses the meteorology observation lab. Together with the first science module, these units support vital projects, from ozone and weather monitoring to space weather studies, aurora tracking, satellite protection, and even spaceflight simulations to study how isolation and darkness affect the human body. In summary, every inch of Halley VI is designed with the intention to support science, protect people, and adapt to an environment where failure isn't an option. Halley VI is a bold response to one of the harshest environments on Earth, built to endure darkness, isolation, and shifting ice. It redefines resilient architecture. Its systems, power, water, waste, and habitat work together to keep people alive in total isolation. But what stands out is how engineering, psychology, and logistics are woven together to support human life day after day. This station may sit on the edge of Antarctica, but its lessons reach far beyond. The principles behind Halley VI, modular design, energy efficiency, and self-sufficiency are the same challenges we'll face when building habitats on the Moon or Mars. In many ways, Antarctica is Earth's rehearsal space, and Halley VI is showing us what might be possible next. It's the kind of achievement worth remembering and sharing, and that's why we created this Halley VI poster, to capture the ambition and ingenuity that makes this station so remarkable. And we're giving one away. To enter the giveaway, like the video, subscribe, and comment below. What surprised you the most about the Halley VI station? We'll announce the winner in the next upload. Or grab one for yourself. It's only available for a limited time. The link is in the description. Before we go, we want to announce the winner of our last giveaway. Congratulations! A huge thank you as well to all of our Patreon and YouTube membership supporters. Your support truly makes videos like this possible. Thanks for watching. Stay curious.